Hey guys, today we're going to be talking about finding the area of rectangles, squares, parallelograms, and triangles. This should be a review, but make sure that you have your notebook out and you're ready to take notes or look through your notes and make sure that you've got everything in there that you need. So this is going to be a very good example of the different equations for squares and rectangles. So real quick, let's start right over here with the area of squares. Because squares have all sides congruent, you can find the area of a square by doing s squared. Now remember that little exponent 2 right there means that you're multiplying the base together that many times. So you're multiplying the side lengths since they're all the same together twice. So in the example down below, you see that you have the side lengths of 6. Therefore, to find the area of that square, you would do 6 squared, which is the same thing as saying 6 times 6. And as you know, that does equal 36. And remember that we always record units of area in square units because we're talking about this amount of space inside of a 2D shape. That's how you tell your reader that you're talking about the area. Now for the area of a rectangle right over here, we like to say area is equal to base times height. So the reason that we're going to talk about base times height instead of what you might have learned before as length times width is because as we get into more complex shapes who have very difficult area formulas, we like to refer to the base. Now it doesn't matter which side you identify as the base. As you can see here, I would have called that the height based on the way that the shape is drawn. But if you were to turn that shape so it was more like this, then that would be the base and that would be the height. So it's just kind of turned on its side. And as you can see down here in the example, it really doesn't matter which one you identify as the base, which one is the height. You are going to get the same area. So in this example, it's 12 times 5, which you know is 60. And again, we're going to record that in square units. So for squares and rectangles, you can use the equation base times height. We did talk about the area of parallelograms right before we left on all of these crazy snow days, but I do want to review that as well. So if you look up here at this top shape that you've got, you know you can see it's a parallelogram, and you can see that they have identified that the height is going to be wherever it meets at a 90-degree angle to the base. So this line right here is the height. This diagonal line on this side is not going to be the height of the whole shape. It's actually going to be a little bit longer. So we want to make sure that we do not get confused and use that length in our formula to find the area of parallelograms. And what they did to show you how to find this equation to find the area of parallelograms is they cut the parallelogram where they found that height. And they took that triangle and they moved it over to the other side. They moved it right over here. And in doing so, it's just created a rectangle. Since we know that the area of a rectangle can be found by doing base times height, I now know that I can find the area of parallelogram by also doing base times height. Now again, it's very important that your height that you use meets the base at a 90-degree angle. Otherwise, you are not using the true height and the area is not going to be correct. All right, one thing that I do want to go over with you guys that we have not talked about before is that this formula for the area of parallelograms can also work for the area of a rhombus. And that should make sense to you since you know that a rhombus meets all the attributes of a parallelogram, and they're very, very similar except for the fact that a rhombus does have all 4 sides congruent. So you can actually find the area of a rhombus by doing s squared as well, just like you did for a square. But I want to make sure that you realize because parallelograms and squares and rectangles and rhombuses are all so similar and can be made into that same shape with those right angles, they can all have the area formula of base times height. All right, guys, so now I want to talk about finding the area of triangles. So here's our example triangle. And I know that in class, we kind of experimented with it, but unfortunately, we don't have a bunch of time for that right now at the moment. So I just kind of want to go over how this formula works. So to find the area of a triangle, we're actually going to double the shape, and we're going to go back to that formula for the area of a rectangle. So what I've just done is I've doubled that right triangle that I originally had by putting another one right on top of it. And now, if you look, my shape is a rectangle. And to find the area of a rectangle, I know that I want to do base times height. However, since my main triangle that I started with is only half of that rectangle, I can go back to my formula and say I only want half of the base times the height. So to find the area of a triangle, the formula that we're going to be using is 1/2 times the base times the height. Okay, you can also do the same thing by just doing base times height divided by 2. You can also do base times height times 5/10, because 5/10 is equal to 1/2. So it's really up to you exactly what kind of formula you would like to use. But the fact that we can manipulate these shapes by doubling them and then cutting them in half to find the exact area is going to be very important for you when we learn the next few shapes. So if I was going to go ahead and solve for this triangle, I would take my base, which is down here at 24 inches, and I would multiply it by my height. Remember, height has to meet at a right angle, which is equal to 7. So 24 times 7 equals 168. But that would be the area for this entire rectangular shape. But I only want half of that, so I need to eliminate that half of the rectangle. So I can divide it by 2 or times it by 1/2, and my final answer after I divide it by 2 should equal 84. Since I know that my lengths are measured in inches, it's going to be 84 inches squared. Never forget those units squared, otherwise the answer is going to be marked wrong. I do want to draw attention to this diagram here, since the last example that I used for finding the area of a triangle was a right triangle. You have to find the height at 90 degrees to that base. So if you look right here, that's where the height is going to meet that base at 90 degrees. Yes, it looks like you're adding on to that triangle, but remember, to find the area, we're going to divide it in half anyways, and it is okay to do that. So even over here in this triangle, we've got our base down here. Even though we have 2 different side lengths, the height's going to be whatever meets that base at a 90-degree angle. So as you can see here in this image, I do want to have one last quick reminder of the difference between perimeter and area. So all of those formulas that we just went over was going to be for area, which is the space inside of a 2D shape. Perimeter is the space around or the distance around a 2D shape. Again, if you have any questions, make sure you put them in Google Classroom, and you can now go and do your 5-question homework assignment in Google Classroom.